Good morning, my dear students. So, today in these sessions, we are going to learn regarding the identification of potential source of energy loss. So, according to examination's point of view, this is the most important topic. So, we are going to learn identification of potential source of energy losses. Okay, so we know very well when the energy is transferred from one form to the another form or move from one place to the another place, from one system to the another system, there is energy losses. So this means that when energy is converted to a different form, some of the input energy into a highly disordered form of energy like heat. Is it right? So what about the transportation, operation and conversions from one form to the another form? Okay, so power generation in a power station pass through the large and complex network like transformer, overhead line, cables and other equipment reach at the end user. The unit of power generated at the power station does not match with the distributed unit to the consumer. So some of the percentage of the units is lost in the distribution network. We are going to learn in the identification of potential source of energy losses. Okay. So we know very well when the energy is transferred from one form to the another form, or energy is moved from one place to the another place, okay, or from one system to the another system, there is energy losses. Is it right? We know very well. So I am writing the same statement. When energy is transformed from one place, okay, it is visible, one form to another, or moved from one place to another place, okay, or from one system to another system, there is energy losses. There is energy losses. Is it right? So what I'm telling you here, when energy is transformed from one place to the another place, one place to the another place, or it is moved from one place to the another place, or it's moved from one system to the another system, there is energy losses. Is it right? So this means that when energy is converted to a different form, the sum of the input energy into a highly disordered form of energy like heat. Is it right? So this means that when energy is converted okay when energy is converted to a different form, the sum of the input energy into the highly disordered form of the energy like heat, we know very well. The sum of the input energy is into a highly disordered form of energy. For example, like we can say as heat. Okay, then we have to know about regarding the what are the losses due to the transportation and operation and conversion from one form to the another form. Is it right? So I will write the topic here: transportation transportation operation and conversion from one form to another form. Okay, dear. So, generally we know very well the power generated in the power station. When we are generating here, the power we are generating in the power station passes through the large and complex network like transformer, overhead line, cable, and other equipment and reach at the end user like customer. Is it right? The unit of power generated at the power station does not match. What I'm telling here? So I'm telling that the unit of power generated at the power station does not match with the distributed unit to the consumer. The some percentage of unit is lost in the distribution network. Okay, the first point I will representing here. I think so it is visible. Okay, power generated in power station pass through the large and complex network like transformer, overhead line, like cables and other equipment and reaches at the end user. At the end user. The unit of power generated at the power station does not match with the distributed unit to the consumer. Is it right? The unit of power generated. So where we are generate the power? We are generate the power in the power stations. The unit of power generated at the power station. At the power station. So power station does not match with the distributed unit to the consumer. With the distributed unit to the consumer. To the consumer. The some percentage of unit is lost in the distribution network. Okay, some percentage of the units is lost where here in the distribution network. In the distribution network. Okay, and this difference in the generated and distributed unit is known as transmission and distribution loss. What we can say here, this difference in the generated and distributed unit is called as transmission. What we can say here, we can say as transmission, or we can say as distribution losses. What we can say, distribution losses. So generally we understood that the power generated in the power station passes through the large and complex network like transformer is there, overhead line will be there, cable is there, and other equipment, and reach at the end user. The unit of power generated at the power station, it does not match with the distributed unit to the consumer. Okay, the some percentage of the unit loss in the distribution network. So this difference in the power generated and distributed the power unit is known as transmission and distribution losses. So they having the two types. The first one is technical losses. The technical losses about 22.5 to 30% of technical losses will be there. The technical losses is also broadly classified into two types. The first one is the fixed losses, another one is the variable losses. The fixed losses, it causes the leaked current losses as well as dielectric losses and open circuit losses. What about these variable losses? So variable it causes impedance losses will be there, and loss caused by the contact resistance. Understood here? So I am telling that this technical losses about 22.5 to 30% losses will be there. This technical losses is broadly classified into two types. The first one is we can say as fixed losses, another one we can say as variable losses. So fixed losses causes like leaked current loss. Okay dear, another loss is dielectric loss, and third loss is open circuit losses. So this is a fixed losses. Is it right? Another one is variable losses. Sometime it should be increased or sometime it should be decrease the losses. So variable losses due to the first thing is impedance losses, and another one is losses caused by the contact resistance. Okay, so this difference in the generated and distributed unit is known as transmission. What we can say here? Transmission. Okay, and distributed loss. Transmission and distribution loss. So they are two types. They are two type. First one we are going to learn regarding technical loss, about 22.5% to 30%. So this technical losses is classified into two types. The first one is the fixed losses, another one is the variable losses. So fixed losses also broadly classified into three types. First one is leaked current losses. Due to the leakage, the current losses will be there, as well as dielectric losses will be there. Okay dear, as well as open circuit losses is there. Okay dear, and the variable losses is, first one is impedance losses, and another one we can say as losses caused by the contact resistance. Losses caused by contact resistance. What is the reason behind of these losses? First reason, okay, what is the first reason? Because the lengthy distributed line, because too much lengthy, it causes the losses will be there. If the length of the line, if it is less, losses will also very less. Is it right? If the length of the line is too much lengthy, so it major losses will be there. So first reason is lengthy distribution lines, first causes. And second reason is bad workmanship, because some of the people is not doing the work properly. Bad workmanship. And third one we can say as load factor effect on losses. And fourth one we can see as transformer sizing and selection, that is play very important role to reduce the losses. Transformer sizing and selection. Fifth one is switching of transformer. Okay, So switching off transformer. As well as second is, okay, it's visible, okay, now is okay. B, just now I told you there are two types. First one is technical losses, another one is non-technical losses. So we can, this non-technical losses we can say as commercial losses. What we can say here? Commercial losses. B point is non-technical losses. So we can say as commercial losses. Okay. Okay. So the energy losses in the pipe flow. Energy losses in pipe flow. So when a fluid is flowing through a pipe, the fluid experiences some resistance, due to which some of the energy of the fluid is